All right, the next part they give us here is that there's a 6,000 in this particular area. And that means the scale factor to the third power times 6 is going to be 1,000, well, or 6,000. So, well, what number times 6 gets us 6,000? That's not bad. That's actually pretty straightforward. So that means that we're going to have some number. This 6 times 1,000 is 6,000. Well, what number times itself 3 times would give us 1,000? Well, it can't be 8. So what if I did 9 times 9 times 9? Nope, 29. We're getting close. So then 10 times 10 times 10. Hey, look at that. It turns out it's 10. So the scale factor here would be 10. That means that we would have a 10 by 20 by 30 size box. So that means this is going to be scale factor squared. It's going to be 10 times 10 is 100. 100 times 16 is going to give me 1,600 there. I still take that though, coming across, it's going to be, so scale factor to the third power, so 1,000 times 0.5. Well, 1,000 times 0.5 is 500. And then I would do that 1,000 times 1,000. It's going to give me here 1,000 times 1,000. Ooh, it's going to be 1,000,000. All right, there it is. All right, so number 2, we kind of figured this out. So what growth patterns do you see in the volume and surface area? Well, it kind of comes down to what we've already talked about a little bit. When it comes specifically to the volume, basically we see this going up really, really fast. But it turns out this is going to be, like we said, this is scale factor to the third power times 6. That's how we get that number there. And then when it comes to surface area, it ends up being, it's like that scale factor to second power. So it's going to be scale factor squared, but times 16 gets us that number there. That's how we're seeing that growth factor play out. But before we go on there, they didn't ask us about this information for decompose, but this also is happening. This is going to be scale factor to the third times 0.5. And this is also going to be scale factor to the third times 1,000. That's our pattern that we're seeing there. All right, part D. Suppose a large compost box is similar to 1, 2, 3 box with a scale factor of F. So that means we don't know the scale factor, but it's just any number that's going to be out there that we don't know about, okay? So here we go, D1. How is the surface area of the large box related to that of the 1, 2, 3 box? Well, if we know that the scale factor is F, and it turns out that in this case, the surface area would end up being the idea of this scale factor squared, and it would still then be times 16 to get that part there. That's how we would know what the surface area is. D2, if both boxes had tops, would the relationship of surface areas change? And explain. If there were boxes with lids or a top added to it, it would not change anything. The scale factor would still be happening. The surface area would still have the same pattern. It would just be another part of it, but it would still increase in that same relationship of that scale factor being squared. So there'd be no change. That is no change except that the surface area would increase. D3. How is the volume of the 4, 8, 12 box related to that of the 1, 2, 3 box? So the volume of the 1, 2, 3 box is 6. The volume of the 4, 8, 12 box is 384. So how are those guys connected? Well, if you remember, the ways that we got this from here, scale factor to the third power times 6. So scale factor to the third power. So let's see what that is there. Remember, scale factor, it would be 8. No, sorry, it'd be 4. So 4 times 4 times 4 equals 64 times 6. Yeah, 384. So basically, it's going to be that it is going to be the scale factor of 4 to the third power, which is going to be that idea of it's 64 times bigger. All right, D4. How's the amount of decomposed garbage related to the volume of 1, 2, 3 box. Well, what we notice here, in that same process here, it was going to be that scale factor to the third power times 1,000. So whatever the scale factor is, so again, it's scale factor to the third power times 1,000. That's how that would be playing out. That's how it would change that information. Wow, that was a lot. Hopefully it made sense. But we'll talk through it more. You keep watching the video. You can ask me questions as we go. But for the ACE work, what we have here on this is going to be just numbers 8 through 11. So let's take a look. Suppose that a company sells laundry soap in boxes that measure 4 inches by 8 inches by 12 inches, and the company wants to offer large economy sizes. What changes in dimensions would give the box double the volume? What changes in dimensions would give the box triple the volume? What changes in dimensions would give the box half the volume? So think about what we did in class today to understand that. Literally, given the scale factor below, find the volume of the similar boxes. So if scale factor is 2, scale factor is 1.5, scale factor is 0.5. So what does that? How does that change the volume of the box? Number 9. You want to make a compost box bigger than the basic 1, 2, 3 foot size. Your friend says if you double each dimension, you'll be able to double the capacity at only double the cost of the materials to build it. Is your friend correct about doubling the capacity? Why or why not? Is your friend correct about doubling the cost? Why or why not? Don't forget to look back at the work that we already did on this today. Number 10, the city of Centerville plans to dig a landfill in the shape of a rectangular prism. The landfill is 85 feet deep, 200 feet wide, and 700 feet long. How many cubic feet of garbage will fit in the landfill? What information do you need to determine how long the landfill can be used until it is full? The city manager says that an increase of only 10% in each dimension would increase the capacity of the landfill by 33%. Is she correct? And number 11, Sean's hobby is building model airplanes and ships from kits. One of his projects is a historic sailing ship. The actual ship is related to the model of the scale factor by 200. So the model is going to be size 1 times 200 to get to that there. So you have these questions. Is the length of the model 25 centimeters? If it is 25 centimeters, what's the length of the actual ship? If the length of one mast, the actual ship is 300 meters, what is the length of the mast in the model? If the area of the deck on the model is 20 square centimeters, what's the area of the deck on the actual ship? If the model ship interior has a volume of 100 cubic centimeters, what's the volume of the interior of the actual ship? All right, guys, so we got a little bit of a revisit of all that old scale factor stuff. Hopefully you remember it. Remember, scale factor is whatever it is times that existing number to show that it's going to be related, and that's going to be multiplied all the way through because it needs to be scaled. So, hope you guys are doing well. We'll catch you next time. All right.